Okay, this is Hu Xijian. This is Hu Xijian, and this is my presentation for the software architecture design. And my project for the Scissor Paper Rock game, and this is simple game. The scissor beats the paper, and paper beats rock, and it's like that. So, um, I choose to force the users input the number, and for one represent the scissor, and two represent paper, and three represent the rock. And the computer will random choose another number same to 1, 2, 3, and then we will be compare these two numbers and get the results. So the two options of my architecture is the pipeline filter and rule-based. So first is the pipeline filter. First, you can see the level 2 architecture is get the input from the users and then go to the pipe 1, and the next filter, the computer will check what number the users input, and if just assume if it's 1, and we'll go to the topper's filter, the scissor, and if it's 2, we'll go to the medium, and if it's 3, go to the bottom. And it's a class diagram. The first is this main, and you can input here and then send to input filter, and will be read these numbers and send to the this. This will be check what number you input, and go to here. Let me see the code. It's like the switch. How to change to the so it's stuck here. The code. But 人群。
I want to refresh. Where is which button is for presentation?
I don't know. The consistent.
Which button is for presentation? Yeah. I think it might be related to the resolution that you have selected. But it was
Oh, yes. Yeah.
Okay.
yeah, that
Maybe
doesn't
he's-
show, it
maybe
doesn't
he's-
show up
Maybe he's
anymore.
using Duo.
What?
Oh,
It's
Okay.
a dual screen.
oh, the dual screen.
Yeah.
Okay. Thank you.
Oh, okay. Oh, so this is to check what number the user inputs, and it will be 1, 2, or 3, and go to the pipe, and the pipe will send the number to the next filter, and we back to the. Right, so this is filter, and second is the rule-based. Rule-based have three components: the user interface, inference engine, and the knowledge base. So the user interface should be the user input the facts and rules, and this is use called the Darwin. Yeah, it's a use-based engine for this architecture, and first create the KIA. The KIA is the application program interface. It can connect the user interface to the knowledge base. And the second part is the get input from user and get the truth from the computer. Then the user interface will connect to the knowledge base. Like if you input the 1 and the computer choose 1, then it will be match the rules and will come to the output. And this is the class diagram. I will send to the code. change this. Yeah.直接把它放在它现在屏幕不行，所以不用它写这个，我就不行。那你要这样一条，我手枪。Here's for the rule base, and first this part is to create the Kia, and then here is to input the numbers and get numbers and create a random numbers. This insert is to create a fact to the knowledge base, and the knowledge base is like this. It have the 8 rules, and if the value is the number you input, and the value is the computer create, and input is the number you input, and like the input equal to 1 and the value equal to 2, and will be print the scissor versus paper, and you will win. And this part is to read the knowledge base, and this part to read the numbers, the number you input and the number computer choose. Yeah, yes, yes. Yes. This class diagram. So this is the mean, and this creates the key and gets a random number, and this is gets the number of your input and get a number of the random number, and use the key to connect the knowledge base, and this is the 7 rules. So the five factors advantage is simple, and you can use independent program, and data structure easily serialized. And the disadvantage is interactions required between components. This architecture is easy and easy to program, and but if your architecture is complex, it's maybe difficult hard to carry out. And for the rule-based, so rule-based user can enter the facts and rules into the knowledge base, and get the results. This is fast, and when way. And the rule-based, the disadvantage of this is if the number of rules is large, it may misunderstand it, and no interaction between the rules present. And for my system, I think the rule-based architecture is more suitable because it's easy to change the rules. And for the pipeline filters, if you want to change the rules, you have to change a lot of part of the program. And for the rule base, you just change the rules, then it's done. And the pipeline filters, for this, you have to go through the whole program to get the results. And in the rule-based system, once it's matched the rules, you can get the result you want. and it's easy to create a rule. Sometimes maybe the rules is complicated. You have the big if then, and for rule base it can separate these rules into different parts. Also, it's maybe more simple, and send please that your
It's going to be a due monitor again. I think so. See? Copy this. Apply. I don't know what you did, but yeah, I changed.
for the this line the rock paper when Caesar please select your hand and you choose one and the computer will choose one so it is draw and maybe you can choose three and still three and this time choose one can choose one so it rock versus Caesar and you win. So that's it. Thanks. Any questions?
It's pretty good presentation, except that it was interrupted frequently. But it doesn't matter. The main thing is that I saw a lot of missing components in your level 2 diagram and the class diagrams in both architectures. So for example, you didn't specifically specify the type of connectors and some links between components are missing. But you did provide some good rationale for the final selection of the rule base, and you did live demo, which is good. Pretty good presentation.
interrupted or something, but I have a backup. Alright, so my project's called Cars DB, and my name's Connor Knudsen. So my project is going to be a database of new and old cars, just pretty much anything on the market that you can buy. It's going to contain specifications and information, and also pictures, although I haven't implemented the pictures yet. I'm still working on that. The idea is that it's a database you can sign up for, and it's also going to be community supported. So it'd be really hard to get an exhaustive list of all the cars out there. But if everyone signs up, has a car that they want to have on there or look up, and it's not on there, if they add that car, then it'll be a pretty good list of everything with all the specifications that people want to see. So you'll have the ability to add cars, pictures, and information if you're a user. You can also search and sort the cars by various criteria. So there's like a search bar, and you can also just sort by like engine type or etc. So my first option that I looked at to do this was a client-server style. And this is my component diagram. So as you can see on the top would be the clients, and those would be the users when they log into the website. Then from there, they can look up cars, or if they can't find one and they want it in there, they can add it, hopefully. So there would be like a procedure call to request info on a car, whether that be search for a car or search for all cars that have V6 engines or something like that. And that would go to the server, which would interpret the searches and query the database and send back up that information to the user. There would also be another procedure call if they wanted to, instead of request info about cars, add some info about cars. And that would also go down to the server, which would interpret what they want to add and insert it into the database. So here's my class diagram for that. And it's pretty simple, which is one of the reasons I like this option. So the garage class you see kind of in the top middle, that would be what I would do for my server. And so that would have a array list or something similar of a bunch of users. And so anytime someone logs in, it'll create an instance of a user, and then that user can interact with the database through the garage class. Here's my mapping. So the client that you saw on the component diagram is implemented in the user class. Request info is actually a method, and that's the query method, and add info is the add to DB method, and then the server is implemented through the garage class. So my second option was the publish subscribe style. And the reason that I thought this one might work also is because you could then subscribe to this list of cars and view which ones you want, and then get notifications when other users added new cars. And so that would be a kind of way to hold interest and stuff. So in this one, you can see on my component diagram, the top level are the subscribers, and the servers at the bottom, and in between there are the stream and the event. And so in the stream, then people can add cars and info, and the server deal with that with the database. And on the event, anytime a new car is published, it'll publish out that car to the subscribers so they can see anytime someone adds a car or something like that. So here's the class diagram for that. It's a little bit more complicated, but the garage class is still implementing the server, and it interacts with the database. And you still have user classes that anytime someone logs in, it'll create an instance of that user class. And then I made a class for the stream and the event also. so that that's how the user can interact with the server through those classes anytime. Like the stream will be anytime they want to add information to the database, and the event will be anytime that new information gets added and all the other users can see it. So here's the mapping for that. A subscriber is again implemented through the user class. The stream component of the diagram is the stream class, event is the event class, and the server is implemented through my garage class, which will kind of deal with the database and handle all of the cars in the system. So this is the pros and cons of them. So the client server I like because it has a little bit simpler implementation for my application. It has direct communication between the server and the clients through method calls. It's, in my opinion, a little bit more fitting for my application. The other one, once I got into it, it seemed a little like I was kind of forcing that architecture style on my program. So this one I also think encourages users to add information because with a publish subscribe, I think if they got like a notification every time a car was added or a new picture or new information, that it would encourage people to just wait around for someone else to add the car. Well, whereas for here, if they don't see the car in the client server, they might not get an immediate notification when a car is added. And I think that would encourage users to add cars on their own, which would help expand our database and make the web app better for everyone. The downside is the classes are less broken up, and so they're a little bit larger each and a little bit denser. And it would be harder to implement a notification system, and a notification system might be cool just to hold people's interest if they got a notification that, hey, a new car was added or something. They might want to go into the web app and see what it was. The parts I liked about the publish subscribe style, so there's more division of functionality, which is pretty good. There's also the ability to easily implement notifications through the publishing. So anytime anyone would add a car, that everyone could see that, and that might hold interest in the application a little bit better. The downsides of that are the implementation's a little bit more complicated for my application. The communication between the server and the client is not direct. It goes through those stream and event classes, so that's a little bit more convoluted in my opinion. I don't think it fits my application quite as well as the other one. And I think because of the whole notification when someone adds a car or adds information, I think it encourages people to wait on other people to expand the database, and I think that would kind of hurt the application a little bit. So I decided to go with the client-server architecture, and the reason was I think it's simpler and cleaner to implement for my particular program. The server will interact with the database, and then the client send additions or searches straight to the server, and it's really easy. So I did screenshots. This isn't really the compilation because it's just a web app, but this shows this is the landing page you'll hit when you go to my website, and you'll see all the fields are populated in the HTML and everything, and it's got a background and this little banner in the middle, so it looks nice and everything. Here's the registration page. So the first thing you'll do after you hit that page for the first time is go to register if you want to use it. And so there's fields to enter your email address and password and then confirm your password. And so that'll just add you into the list of registered users. Here's the login page. So if you come back after you've already registered, you just log in and you only have to type your password once, obviously. Then here's the search and sort I implemented. So this is kind of a zoomed in view of the top left. And you can see in my navigation bar at the top, I've got the home button and then a sort by, and that's a little drop down list. And so those are just kind of pre-made search things. So you could search by manufacturer or engine type or engine location, drive wheels, transmission type, body style, or model year. So those are things that I think would be commonly searched for, and so I implemented that in a pretty easy to use way. Then next to that is the search bar where you can just search for general terms, and then the submit button for that. So here's the results page. So for example, this search was rear-wheel drive, V8, and four-door, and it only pulled up one car because the database doesn't have a bunch of stuff in it yet. But for example, that's a 2014 Chevrolet SS, and I plan on making this look a little prettier too, and making that a clickable link so that you can go to the page for that car and view more information and hopefully pictures, but that's still being worked on. And so that's what you would see after you did a search or a sort by. And that's everything.
Good. That's a very neat presentation.
Thank you.
Just one little comment on
Yeah.
your comparison of pros and cons of publisher subscriber versus client server.
Mm-hmm.
And it's not saying that, not very appropriate to say that publisher subscribers is to encourage the user to add more information, because we can design a system to allow the user to acquire the information while adding the information in parallel.
Okay.
So they do not need to be one depends on
Mhm.
one depends on the other.
Okay.
Yeah.
Thank you.
As the first day presenter, I think it's very important.
Thank you.
Usually more encouragement for the first day presenters, but later on, I think the grading criteria would be more strict. Later in the exam for the presentation, you already got a lot of examples. So as I promised last time, I'm going to go through, give you a brief tutorial about C2 Saddle. It's the starting of homework 3, our final homework assignment in this class. Hopefully the workload is not too heavy for this class, especially towards the second half of the semester. I tend to let you focus more on the final presentations. So first of all, let's take a look at the homework assignment. So the last homework assignment requires you to provide a architecture description of a subset for the C4 systems using the C2 Saddle architecture description language. So C2 Saddle is an architecture description language which was created by the software architecture group in UC Irvine. And they were the originator of UC Irvine, and afterwards when Nino moved to USC, so basically he originated the component and the connector software architecture, the C2 software architecture. And C2 Saddle is something that is most compatible with the C2 architecture. But C2 Saddle can be used also to model all kinds of software architecture as well. So the C2 Saddle ADL should reflect the architecture breakdown and the topology given in the following figure. So specifically, in this assignment, you are only expected to provide the full expectations of the following components, not all the components. So first of all, based on this diagram, you should provide an overall infrastructure, the overall infrastructure of topology of the architecture using C2 Saddle, right? Which means you have to define the component
define the connectors and define their configurations. Okay, but for the full specification of the components, you only need to provide the full specification to two components, online database and offline database, three components, online database, offline database, and the billing system. So these are the three components you need to provide us the full specification, including the attributes that are defined, the operations, and configurations. So, and the architecture specification you provide must meet the following C4 system requirements, which means the architecture description notations, architecture description should be faithfully implement or specify the architecture you would like to design in order to fulfill these C4 system requirements. The first requirement is automatically daily updating of the offline database. And based on, I believe that you have read the Anderson Consulting's description about what are the overall design, the requirements for designing the C4 system, right? So automatically, daily updating of the offline database is based on the scenario that after 24 hours each day, and you collect all the transaction data from the online database. And the system should be able to automatically update and dump all the online database transaction record into the offline database. And the second requirement is to support for concurrent tasks. And the third requirement is for supporting the long-lasting interrupted sessions of a phone call. For example, when a customer calls the C4 center, right? But the phone call was interrupted in the middle. Is there any way that you can implement your system to allow the system to pick up whatever left during their conversation when they were interrupted? So you need to make use of some specialized operations or fields that are defined in the database to accomplish this goal. And in addition, you need to incorporate a mechanism for generating reminders to assist the customer representatives. So for example, you need to support a pop-up at the time requested by the customer. And you may, some involved components besides those three components may be the PC task processor and GUI, local transaction state, and online database. But they only need to provide me the full description, specification of ADL for online database. For the other two related components, you only need to provide me a very top level specification without detailed fields, without detailed operations. I think the related components can just be included in the overall architecture diagram. That should be fine. And for further ease your life, as originally, I should not have to provide you to these fields information, but to further ease your life, considering you're coming to the end of the semester, I specifically provide you the database fields for you to put in your design. However, you feel free to add your own fields as necessary. So basically, you can assume the online database will include at least the following fields: the name, the date of birth of customer, social security number, address. Phone numbers can be one or multiple phone numbers. Voicemail option, caller ID, three-way calling. Those are the services provided by the call center. Numbers called or services accessed. Long distance provider, numbers called, and duration during the past 3 months. And for the offline database, because it's a permanent storage of organized or synthesized transaction record. So it contains less field than the online database, because we would like to synthesize and try to make the record more concise for permanent storage. So basically, we only record phone number, numbers called, and duration during the last 3 months, the rates for billing, the amount charged per phone call. So it's most like the billing statement from a cell phone company, right? So the billing statement can display the customer bill by the phone number. So you should support the searching of customer's bill by the phone number, or support other searching mechanisms. So bills are generated only from the offline records. So C4 does not interact with the billing system, but it works against the same set of databases. So more specifically, C4 interacts with the online parts of the corporate databases, while the billing system works with the batch copy of the online, which is basically the offline databases. And the monthly bill is done in a number of cycles. For example, the monthly bill should be printed every month based on different customers' due dates. And each cycle processes the billing information of a set of customers, and all updates to the data of the current cycle are halted until the end of the cycle. It applied only to the online data. And the updates are done in batch and are transparent to the C4. So for the connector type, you need to define for your architecture. We assume that the message filtering mechanism of all connectors that are used in our application is no filtering connector, no filtering message connector. So let me give you a brief introduction of the syntax of C2SADO. So C2SADO was developed at USC and UC Irvine, and it basically balanced the formality and the simplicity with a small number of language constructs. So it's pretty easy to learn. And the semantics described in first logic order. So basically, you can use the inherited data type, for example, the integer, the natural, the float number, or the character, the string that was defined in C2SADO, just as those basic data type that has been included in our Java library. On the other hand, when defining the name of the fields and the name of the method, you feel free to use your own name for the fields, and you do not need to provide a specific specification of the internal data structure. How, for example, if you would like to record multiple phone number for a customer, you could create a field, specify a field like phone numbers. That's it. You don't need to tell me whether you're going to use array or vector to store phone numbers, right? You can choose the field name which makes sense to the application and makes sense to the developer. But you don't need to go into the detail, go into the depth of data structure. So we are not in the level of coding and implementation. And the description of C2 components does not include the description of request and notifications. So in this C2SADO ADL descriptions, you do not need to include the differentiation of requests and the notifications in the specification. And in this C2 saddle specification, we specifically separate the specification of provided interfaces versus the required interfaces. So it defines how the message is, whether the message is sending out from a component or received by a component. So this is a basic structure, the syntax template for the C2 saddle specifications. So you start by describing the architecture of a system like C4. You can name your system as simply as C4. The C4 should consist of the definition of components type, which contains the subtype specifications, if needed, the state variables, which basically are the fields of the components. The invariants. So what is invariance? Invariance means you need to specify the first order logic to define some constraints that the components, as long as it's alive, it should always conform to some constraints during the entire operation lifecycle. So the fourth compartment is the interface description. So basically, you define interface for the operations, and then describe the behavior to implement each interface. So for the behavior or operation descriptions, it's just it's exactly the same as you're writing a pseudocode for your program. You should define the local variables that can be invoked inside the operations. And so, which means anyone outside of this method, this operation cannot invoke this local variables. So this is why we call it a local variable. It's only visible to this operation. And for each operation, you should specify the pre and post conditions. So also, most likely they're in the first order logic as well. So precondition means what is the precondition when the components needs to be invoked. So what condition must be satisfied completely to invoke a component's behavior. The post condition means after an operation is done, what is the states which is expected to be satisfied after an operation is completed. And then finally, you need to map the interface to the behavior. So basically, behavior should be the specific operations that is connected with a public interface. So interface will be publicly available to other components. And then the next part is the definition of connector. So it's very simple for connector type definition in our assignment, because all the connector type is defined as no filtering message passing connector. That's it. We don't differentiate different kind of connector in this assignment. And then finally, the architecture topology should be defined based on your definition of component and connector type, and try to configure them together. So in this part, you're responsible for instantiate all the component type, connector type. So you can define how many instances you need for each components, and how many instances of no filtering connectors are needs, and define their interconnections. So this is generic templates for defining the C2 saddle architecture. And let me go through a simple example. So C2 saddle supports the definition of state variables as well as the local variables. The syntax for defining a state variable and a local variable should be exactly the same. So it's just like you're defining a variable for your program. For example, if you still remember the Clex example, the Clex game example, when we discussed the C2 architecture style, right? So the the top truth is sending out, is issuing the plates, the plates underneath, and basically we have a device to pick up the plates, and based on the color of the plates that are aligned in the bottom well, and you can align the plates. You can align the tile either horizontally, vertically, or diagonally. And if you still remember the operational scenario of the Klex gaming example, let's take a look at the examples that we need to use C2 Saddle to specify the semantics of Klex game. So for the well and underneath the screen, we need to define the total capacity of the well and to prevent it from overflow, right? So the capacity should be defined as the integer. So as long as the capacity still can hold the more tiles, and we can still let the parachute, the chute to continue issuing the tiles. And the variable can be defined exactly the same way that you define a variable in your pseudocode. So, here integer is the type you would like to have capacity to be, right? So this is the definition of a regular state variable or local variable. And another feature that was provided by C2 Saddle is that the variable can also be declared as a function. A function is a mapping between two variables. So, for example, when we try to locate a specific tile or try to position a tile in a specific place in the well, we have to map the integer to the color, right? So a tile, when they are placed in a specific position in the well, they should be defined with an integer which indicates the position and the color. So it has two attributes, and we have to have a mapping between these two attributes to determine which tile is drawn in which color, right? So well at in something defines a function to show the mapping between the integer, the position of a tile, and its color, so that we can specifically locate a tile with a mapping to its specific color, and so that we know whether there is alignment of the same color horizontally, vertically, or diagonally. So this is something unique provided by C2 Saddle in the variable definitions. And the C2 Saddle only supports declaration of the basic types, but there is no support for the semantic description for the basic types. So when you use the basic types that are included in our C2 Saddle syntax pool, you don't need to explain what's that. You don't need to explain what integer means or what natural means. You can assume that the developer should know about all the basic types. Okay, but when you define your own data type, it's always a good practice to provide a comment of what does it mean. For example, phone numbers. You can, but here phone numbers by its name, everybody can tell it records the customer's phone number, right? So, but for other attributes that are defined by yourself, it's always a good practice to put online comments besides the new fields that you define in the components. So, or in the operations for the grader to know what this variable is used for. And we can do subtyping through the basic types that are defined in the C2 Saddle. So it's very useful for the component evolution, including your self-defined components or self-defined data type. you can also do subtyping. So for example, natural is basic subtype of integer. So natural can be inherited or a subtype of integer. And here, when we try to define the interface for a components, there are several ways you can define interface through the subtyping relationships. So the evolution of the components is supported via subtyping, including the definition of the data type, the definition of the fields, as well as the definition of the interface for components. For example, the well-abstracted data type defines the structure of the well, the layout of the well, for example. So the well ADT can be defined as a subtype of a matrix if you would like to use the matrix as the basic data type that you want to inherit from. But sometimes you would like only to inherit the matrix, the behavior of the matrix, and sometimes the behavior of the matrix only, or sometimes you would like to inherit both interface as well as the behavior. So basically, this chart shows you the relationship between several part in operations that you would like to evolve from. So for each operation, we have interface. And for each operation, we also have implementations to specify its behavior. Right? So the right part specifies the behavior, and implementation is a subset of the behavior. And interface is a subset of the namespace, right? And the interface can be a little bit, can have a small overlap with the implementation sometimes. But sometimes you would like only to provide then the inheritance from the matrix behavior, but not interface. So in this case, you have to use the first order logic to exclude the interface from your definitions. If by default, the interface should be also inherited together with the implementation by default. So this is an example of subtyping definitions for a specific, when you try to evolve or specify a component from a generic data type. So next, how can we define the pre-post conditions and the invariants? So those are very important. Everything should be described in the first order logic formulas using the logic symbols. For example, in the collect game example, there is an invariant for the entire game. So the invariant that should be always satisfied during the life of the game is that the total number of tiles should be equal or greater than 0, and the total number of tiles should be equal or less than the total capacity of the game, right? Otherwise, the implementation should generate an overflow. So this is something that you have to exactly follow the template, the syntax that you have to exactly follow to define an invariant. It always led by a tag of invariants with a bracket and a semicolon after each logical first order logic definitions. So this is an example of a collect game overall as a system to specify the invariants. And the pre and post conditions apply to only the individual operations. So pre and post conditions usually occur in front of the definition of, or inside a definition of components. So they should be, when you define a components, usually you start with defining its invariants, right? And then defining the pre and post conditions of components if it's necessary, but not all components needs invariance, pre-post conditions. But for each operations, you have to define its pre and post conditions. So because each operation, when you try to invoke an operation, it always needs to satisfy some preconditions. And after an operation is completed, it turns the system into another state, which should be expressed by a post condition. For example, the precondition of an operation is that the position should be greater than 0. So this is the symbol. You try to accommodate each of the logic symbols, by lead each logic symbol by the forward slash. And the position should be equal and less than the total number of tiles. And the post condition, after we put a tile inside a well, the final result of this operation should be equal to a mapping of color with the position. So the input parameter should be a position, and the well@, should output a color. So based on our definition, so the integer is used as an input of well@, and it should output the color. So it was defined as a field, but it has an output in this case. So this is a very unique feature that is provided by the C2 Saddle. So, and you can fully use this kind of feature to define your functions. Okay. So well@, will be considered as the results, as a post condition that needs to be understood by the developer. And at the same time, the total number of tiles should be the total number of tiles minus 1, because one tile has been issued and placed in the well. So we have one less total number of tiles. So by defining the state, so the definition of state variables and the local variables are exactly the same. You can define as a basic type your own self-defined type, or an evolution or subtype of the basic type or your self-defined type. So this is an complete specification in C2 Saddle for a component called well_ADT. So well_ADT basically defines how we're going to design the layout of the well. So how can we position a tile which is coming down from the chute and place it into the well. So it's defined as a subtype of matrix, and we're going to use evolve all the interfaces and the behavior of a matrix in designing the layout of the well. And then we start by defining 3 state variables: the capacity of the well, the number of tiles, and the well@, which is later on will be used as a mapping function for us to retrieve the color of a specific position in the well. Okay. So and we start we can define with the basic type or the function type, and then we define the invariant of the well_ADT components. So the total number of tiles should be equal and greater than 0. So each of the symbols that is provided by the C2 Saddle is usually led by a /. Okay. So the number of tiles should be equal or less than the total capacity. And then after defining the invariants, we define the interfaces. So here we differentiate the provided interfaces versus the required interfaces. So in this example, accidentally, we only have provided interface. So provided interface always leads by the tag of prof. And it starts with a unique ID of that interface, GT1, for example. So, and then the semantic name of the interface. Try to make all your names, including all the variables and the method name, operations name, meaningful to the grader. Okay. So the getTile method takes one parameter location, and it will output the color. And there is another implementation, another variant of getTile operation, which can take the input of a natural and output the GS color. So although they belong to the different data types, and they fulfill the same functionality, but it's considered two compatible implementation or design for different client interfaces. Some user may choose to input an integer, but others may choose to input an natural, but get GS color. So you have to provide all the specifications for all variant design, even for exactly the same interface. And the operations is led by prof tile get with operation name and the type, and with a pair of brackets. And here is the definition of the local variables. Local variable always starts by a tag let. So when we define a local variable, we will let the position is defined as an integer. And the pre and the post conditions are defined afterwards. So pre and post conditions defines after all the behaviors, all the activities that is defined by the operation is done. Or when operation is invoked, what kind of constraints we need to satisfy. So precondition means when the tile get operation is invoked, what precondition should be completely satisfied before it's invoked. And postcondition shows what is the afterwards states constraints after the tile get operation is completed. And finally, we need to exactly map the interface with your defined operations. So here we have 3 state variables which are defined in the states. And in this example, accidentally, we only have the definition of provided interface. How do we define the required interface? So provided interface is led by a tag prof, but required interface is led by a tag REQ. So this is the provided. Interface, but this is the required interface. Okay. And the other variation of component definition is to combine the behavior, combine the operation description inside the interface. So we do not specifically separate the specification of interface and operations. But when we define a component, we try to combine everything together. So we tuck all the operations into the definition of each interface. So what's the pros and cons of this definition? So it seems that we can save some space in our specifications. However, you can tell we actually introduce a lot of redundancies, replications, which may introduce the potential defects in our architecture description. So in this assignment, we require everybody to use the first representation to separate the interface and the behavior. And finally, do a mapping, specify a mapping between interface and operations instead of this one. So this one is just for, this example is just for your information. When you see this case, it's also allowable. But we prefer, so in this homework assignment, you are all required to use separate interface and the behavior, and then provide a mapping for consistencies. And but even though I gave you a brief tutorial, you are highly encouraged to read through the entire semantic and the syntactic definitions for C2 Saddle to complete your homework assignments. Okay, is there any questions? So next time, when you come to class, especially for the first presenter, please come to class a little bit early and set up your computer and your laptop presentations so that we don't waste time in transition between students. So next time, there are going to be 4 students who will present. Joe, Puya, Emma, Alex.